So today I have two objectives from chapter 11, objective 4 and objective 6. Objective 4 asks us to place the energy term or energy amount into the balanced equation on the proper side. So I wrote out two equations already, and what I like to think about when I'm doing this is what kind of a reaction is it? Is it an endothermic reaction or an exothermic reaction? So just for starters, if it's a positive value, it's an endothermic reaction, and if it's a negative value, it's an exothermic reaction. So I'll write that in. And then to determine what side it's on, for endothermic reactions, you are absorbing energy. So you require a certain quantity of energy for the reactants to continuously react. So to make this equal out, you need to have this value on the left side, because you need to absorb the energy first, and then you'll have enough energy to continuously do the whole reaction. So in this case, I'll write it out below how it should look. So you just have the same equation, you just add in this value on the left side, because in general the products are going to have more energy than the reactants. So to make it equal out, you have to put this value on the left. And for the equation below, this is an exothermic reaction, and it's the exact opposite. What I like to think is that if it's an exothermic reaction, the reactants exceed the products in the amount of energy. It's a little cheesy, but so in this case, 98.9 will just continue the original equation, but just on the right side. And in an exothermic reaction, the reactants have more energy than the products. So, yeah, that's how you'd write it. And then objective 6. This is asking us to use Hess's law to calculate the delta heat of reactions. So the starred reaction, the top line, is what I'm going to try to calculate. And then the two equations below it are what I'm going to be using to morph to make it equal up. And it's kind of like a puzzle, which kind of makes it fun. And you can flip them, you can multiply or divide to make sure you have the right coefficients and all the right elements on the right sides. So for these two equations, you first look at the elements, and you say, I need a C2H6O on the left side, and there's a C2H6O, but it's on the right side. So for this first equation, I flipped it already, and that's down below. As you can see, I just took the two sides and flipped them. So I'll write flip. And actually both of these equations are going to flip, because also I notice I need a CO2 on the right. The only other place there is CO2 is over here, but it's on the left. So I need to flip this equation as well. And then I notice once you have flipped them both, they're not going to exactly equal out. Like, just for starters, this is 2 C2H6O. We only want 1. When I add this up, I'm going to get 4 H2O. I only want 3 H2O. So we're also going to have to divide this top equation by 2. So I flip it and I divide it by 2. So the new values that I'm going to end up adding up in the end is negative 101 after I have flipped the sign, so it's now negative, and divided it by 2. And the equation below is now going to be negative 583. You just flip the sign. and I'll change these coefficients so they make sense. I've divided all the coefficients by 2, so this will be 1/2, and the rest are just going to be 1. And so see how that works out now? C2H6O, 5/2 plus 1/2 is 3 oxygen, and then 3H2O, 2CO2, and this will cancel out. If they're on opposite sides and they're the same, they're going to cancel out. So we're all good. We just need to add the values now. And that will give you, once you do the math, -685.25. So there you go.